Today we are going to talk about angles. I'm first going to go over what an angle is, how to name an angle, different types of angles, and different type of angle relationships. And in a lot of shapes you see that they have different angles. And sometimes we want to name them. So first, let's talk about what an angle is. So on your notes, go ahead and write down, what is an angle? Well, an angle is made up of two rays that have the same endpoint. So we have this ray, and then this ray, which shares the same endpoint, and together they make an angle. And I'm going to go ahead and put some points on this angle. So point B right here is the endpoint. And these two things right here, this and this, are the rays that share the same endpoint. Another way we name angles is this, or the parts of an angle is this. Oftentimes we'll call this endpoint the vertex, and we'll call the rays the sides. So like side AB or side BC, for example. Part 2. How to name an angle. There's a couple of different ways to name an angle. Let's try some examples. I have angle X, Y, Z. And there are three ways to name this angle. The first way that I can do is I can go from the top to the bottom. So angle X, Y, Z. The second way is I can go from the bottom to the top. So Z, Y, X. And the third way I can name this angle is simply using the vertex. And this way only works if there are no other angles with that same exact vertex. So make yourself a note and write this down in your notes. If you can only name an angle with a vertex if there are no other angles with the same vertex. I'll try to clarify this a little bit more. If I have angle X, Y, Z here, and I have angle M, Y, F, I can't just name this angle, angle Y, because there's another angle here that has the same vertex, and the person that I was talking to would be confused as to which angle I was talking about. At this point, go ahead and go to your packet and try page 7 out. And then when you're done with page 7, go ahead and come back and play the video again. Now we're going to go over the different types of angles. The first type that we're going to talk about are congruent angles. Congruent angles are angles that have the same measure, or simply are equal. Example. We have angle D E, F. And we have angle G, H, I. And they're both equal to 100 degrees. Because they're equal to the same thing, we call them congruent angles. So angle DEF is congruent to angle GHI. Or, for short, you can use a symbol, the congruent symbol, which is this. It looks like an equal sign, but it has a little squiggly mark over the top, and that stands for congruent or equal in measure. And you see this symbol also with line segments and other things like triangles that may be congruent to each other. Okay, the next couple we've kind of been over already in class, but I'm just gonna review them and I want you to write them down. The second type of angle is an acute angle. And again, an acute angle is an angle that is less than 90 degrees. I'm going to draw an example. That angle is less than 90 degrees. Third type of angle, and we've talked about this one also, obtuse angle. An obtuse angle is an angle that is greater than 90 degrees. I'll draw you an example. Fourth type of angle. This one you should all know. Right angle. A right angle equals 90 degrees. And it looks like the corner of a piece of paper. And we represent it using a square symbol. And to represent a right angle, we use a square. The last type of angle that we're going to talk about is a straight angle. And a straight angle looks like a straight line. And the measure of a straight line is 180 degrees. So if you see an angle that looks like a straight line, and that is not a straight line, because I can't draw straight, but you get the idea, this measure of this angle is 180 degrees. Alright, we're now going to talk about angle addition. So what happens when you add two or more angles together? Well, you simply add the degrees together. Angle addition. So basically, you can add angles together. And to do this, you add the degrees of the angles. Let's do an example. We have a diagram that looks like this. We have angle P, T, N, and we have angle N, T, M. We're told that angle PTN is equal to 30 degrees, and we're told that NTM is equal to 40 degrees. And we're told to find angle PTM. Now PTM is this entire angle right here. So what we need to do is we need to add the two smaller angles together. So our equation to find angle, or the measure of angle PTM, and this little symbol right here just means measure of, what we do is we add the two smaller angles together. PTN plus measure of NTM. The measure of PTN, as we can see, is 30 degrees. The measure of NTM is 40 degrees. We add them together, 30 plus 40 is 70 degrees. So our answer for the measure of angle PTM, the bigger angle, the outside angle, is 70 degrees. Alright, the last thing I'm going to talk about today are angle relationships. How do angles relate to each other? The first type of angle relationship that we'll see in geometry are called complementary angles. And these are just angles that, when you add them together, add up to 90 degrees. I'll do two examples. You can see complementary angles that are separate from each other. That add up to 90 degrees. So if this was 30 degrees and this was 60 degrees, 30 plus 60 gives you 90 degrees. So these two angles are complementary. You can also see complementary angles together. You can see complementary angles share a side. For example, you might see two angles put together. They're both 45 degrees. And if you add them together, you get 90 degrees. So both sets of these are complementary angles. Another type of angle relationship are supplementary angles. And these are angles that add up to 180 degrees. And again, just like complementary angles, you'll either see them together or you'll see them apart. Example. You might have an angle that is 50 degrees, and you might have an angle that's, and sorry, these aren't drawn to scale, but you might have an angle that's 130 degrees. And together, they make up 180 degrees, and so they're supplementary to each other. Again, you might see two angles that share a side and a vertex. So for example, if this was 40 degrees, and this is 140 degrees, together they equal 180 degrees. And these angles are also supplementary to each other. A special type of supplementary angles are called linear pairs. And these are angles that form a line together, and they share a side and they share a vertex. So these are supplementary angles that form a line together, by sharing a side and a vertex. I'll draw some examples. The most common type of linear pair that you'll see would just be two angles like angle 1 and angle 2 right here that create a line together. You might also see linear angles or linear pairs formed when you have two lines intersect each other. For example, angle 3 and angle 4 are linear pairs because together, when you put them together, they make a straight line right here. Angle 3 and angle 5 could also be an example of a linear pair because, look, they create a line together. Or angle 4 and angle 6 could be examples of linear pairs because they form a line together. Or angle 5 and angle 6 could be linear pairs because they form a line together. You get the idea. Linear pairs are not this, though. They are not two separate angles, like that. They have to share a side and they have to share a vertex. One more special angle relationship, and we call them vertical angles. And vertical angles are angles formed by two intersecting lines. And they look like an X. Vertical angles are also angles that are across from each other. So if you have these two intersecting lines right here, you get four angles that are created. You get angle 1, angle 2, angle 3, and angle 4. And I'm going to use a different color to kind of show you what I'm talking about. See angle 1 right here and angle 3. They create an X together, and they are across from each other. So angle 1 and angle 3 are vertical angles. And likewise, angle 2 right here and angle 4 are across from each other and create like this X. So angle 2 and angle 4 are also vertical angles. And the cool thing about vertical angles is this. Vertical angles are equal to each other. So if angle 2 right here was equal to 50 degrees, we would know that angle 4 was equal to 50 degrees. Or if angle 1, since angle 1 and angle 4 are linear pairs, angle 1 has to be equal to 130 because together angle 1 and angle 4 make 180. And since that's 130, and we know that angle 1 and angle 3 are vertical angles, then angle 3 must be 130 as well because vertical angles are equal to each other. Let's do an example, and then let's try this example. I want you to go ahead and write this down in your notes. And then when you're done, go ahead and restart the video. So right now, pause it, copy down this problem, and then when you're done, you can restart the video. Alright, we're told in this problem to find measure of angle 1, measure of angle 2, and measure of angle 3. And I noticed that these angles have a couple of different relationships with each other. So I'm going to go ahead and write down those relationships, and then we're going to use them to help us solve for the different measures. So first, I notice that we have angle 72 here, and we have angle 1 right here, and together they make a straight line. So they're a linear pair. And we know that linear pairs are equal to 180 degrees. So we know that angle 1 and the 72 degrees are linear pairs. And are equal to 180 degrees. So we can use that knowledge to help us solve for angle 1. Another thing that I notice here is that angle 72 and angle 2 right here form an X together, or are across from each other and are created by two intersecting lines. So in my mind, I know that angle 72 and angle 2 are vertical angles. So the angle that is equal to 72 degrees plus whatever the angle 2 are vertical angles. Oops, I shouldn't write it like that. That's confusing. Okay, let's try that again. 72 degrees, whatever angle that is, and angle 2 are vertical angles. So what this tells me is that they need to be equal to each other. So we know right away that angle 2 is 72 degrees. And I'm going to go ahead and label my diagram 72 degrees. The last thing that I noticed, or the last two things really, are that angle 1 right here and angle 3 form an X together, or they're across from each other, and they are created by two intersecting lines. So I know that angle 1 and angle 3 are also vertical angles with each other. And whatever angle 1 is, angle 3 will be equal to it because they're vertical angles. So let's go ahead and solve this problem. We know that angle 1 and angle 72, or the angle that is 72 degrees, are linear pairs and they have to equal 180 degrees. So to find the measure of angle 1, what I'm going to do is subtract 180 degrees from 72. So 72 degrees plus the measure of angle 1 is equal to 180 degrees. And then to get the measure of angle 1, I'm just going to subtract 72 degrees from 180. And so I get, say, 10, 8, 180 degrees. And since that's 108 degrees, we know, because angle 1 and angle 3 are vertical angles, that angle 3 has to be 103 degrees. We also know this, and this is really just to help us check to make sure our work is correct. We know that angle 3 and angle 2 are a linear pair, so they need to equal, or they're supplementary, so they need to equal 180 degrees. So let's just check to make sure that 103 plus 72 gives us 180. So 103 plus 72 Oh, oops, it's supposed to be 108, excuse me. I wrote it wrong, my apologies. So let's fix this. 108 plus 72. Let's make sure that gives us 180 degrees. And it does, so we solved for the measure of angle 1, angle 2, and angle 3 correctly. So I'll just go ahead and write it up here again. I'll write it down here actually. Measure of angle 1 we got to be 108 degrees. Measure of angle 2 we got to be 72 degrees. And measure of angle 3 we also got to be 108 degrees. And that's our answer. Go ahead and finish the problems on page 8.